today's edition of Ian Can, You Can, and today we'll be solving 3 questions on how to find the gradient. Let's start with the first question. If the equation of a straight line is 2x plus 4y equals to 3, find the gradient. Now, we write the question. 2x plus 4y equals to 3. To solve this, we use the linear function, which is y equals to mx plus c. So as you can see in the linear function, y has been made the subject. And in this linear function, y and x are the variables, m is the gradient, and c is the intercept on the y-axis. Then we have to make this y the subject. First, remove the 2x, but when it goes to the other side of the equal sign, since it's adding here, it will come to subtract here. Is equal to 3 minus 2x. But the 4 is still here. The 4 will go to the other side. But it's not adding. It's closest to the 1. It means that it's multiplying. So the 4, when it goes to the other side, it will divide. Which means that the equation becomes y is equal to 3 minus 2x divided by 4. Now, since there are two numbers that the 4 is dividing, we split into 2 so that the 3 will be divided by the 4 and the negative 2x will be divided by 4. So we have 3 over 4. Y equals to 3 over 4 minus 2x over 4. Now, there's no way to break down this 3 over 4, so we have to stay the same. Because y equals to 3 over 4. Then the negative 2x over 4. We can break this one down by 2. So 2 will go into 2 once, and 2 will go into 4 twice, which leaves 1x, negative 1x over 2. So, negative 1x over 2. Now, in the linear function, we see that m is the gradient with x by its side. And since this negative 1x over 2 has x by its side, that means that it is the gradient, which means that we form the gradient for 2x plus 4y minus equals to 3.
So what is the gradient?
Now let's
So what is the gradient? So what is the gradient in this?
Negative 1 over 2x.
Good. All right. So we can move to the next one.
Let's go to the next question. Find the gradient of the line which passes through the points A, B, and 1, B, 6, and 10. So we have the coordinates 3 and 1, 6 and 10. Now we have to label them x1 and y1 and x2, x2, y1. Now to solve this question, now it says we have to find the gradient, and since And we can't use y plus mx plus c here. So we use this formula. Change in y over change in x. And change in y means y2 minus y1. And change in x means x2 minus x1. Now, to solve this, we have to label, we have y2 here. This is why we labeled the coordinates as x1 and y1, and x2 is here. And now, it's y2. This is y2. This means that it's 10. And y1 is here, which is 1. Minus 1 over x2 minus x1. So x2 is here, which is 6. And then x1, which is 3. Now 10 minus 1 is 9. And 6 minus 3 is 3. For this, we can break it down. So 3, we're going to 3 once. And 3, we're going to 9 twice. This leaves us with 3 over 1. And if there's any number over 1, it's that number. Which means that this is 3. And that's how to find the gradient with 2 coordinates. Now let's move on to the third question. Find the length of the line A, 3, and B, 6 and 10. Now this may look the same, but see, it says find the length of the line. Finding the length of A, which is 3 and 1, and B, which is 6 and 10. Now to do this, we draw a straight line. A straight line. If we draw a straight line, now we find the biggest number here, which is 10. And we do 1, 2, 3, 4, and y1, x2 and y2. Now y2 is 10. We bring in the 10. And y1 is 1. We bring in the 9. Square. Now x2, this is here, is 6. And x1 is 3. We're giving the 3. And square. Square. 10 minus 1 is 9. So we're bring in the 9 and the square. And that's 6 minus 2, which is 3. So we bring in the square. square is 9 times 9, which is 81. So we do 81 here. And 3 square is 3 times 3, which is 9. Now, we're going to line AB is equal to 90. So it's 81 plus 9 is 90. But there's still square here. And since we're finding line AB, the square goes to the other side of the equal sign. But when this square goes to the other side of the equal sign, it becomes square root, which means our answer as line A is equal to square root of 90. And now, which means that we have solved all 3 of our questions related to finding the variance.